Imagine a solid leather sphere traveling at over 90 miles per hour, crashing directly into a batter's front leg. What follows is an immediate eruption of sound. The fielding team spins around, screaming at the official for an LBW, or leg before wicket, dismissal, claiming that the batter's leg illegally blocked a guaranteed strike on the stumps behind them. Standing at the end of the pitch, the umpire has only a fraction of a second to make a ruling, based entirely on what their naked eye just caught. In that blink of an eye, they have to calculate exactly where the ball bounced, the precise angle of impact on the pad, and guess its unhindered path moving forward. For over 100 years of professional cricket, resolving this complex geometry relied entirely on the isolated, instantaneous judgment of a simple human brain. That biological limitation frustrated a British computer scientist named Dr. Paul Hawkins, who decided to build a mathematical solution in the early 2000s. He developed Hawkeye, a ball tracking system that would bring computational proof to the pitch. During this 2001 test match between England and Pakistan, Hawkeye was first utilized on an international broadcast to digitally track a cricket ball. That match marked the moment sports officiating began transitioning from subjective human guesswork to objective, replicable data. Let's freeze a modern LBW appeal right at the millisecond of impact and pull our perspective wide to look at the perimeter of the stadium. This map highlights the placement of 6 to 7 dedicated high-speed cameras positioned around the boundary. These cameras create overlapping fields of view, working together to constantly capture multiple synchronized angles as the ball leaves the bowler's hand. All those individual frames of high-speed video are then instantly streamed to a central processing hub. The system transforms the physical arena into a continuous flow of raw, three-dimensional spatial data. Using incoming video data, the software synthesizes the angles to generate a precise digital twin of the pitch, mapping the ball's exact trajectory. The first task inside this model is pinpointing the spatial coordinate where the ball pitched on the turf. Next, the software maps the exact microsecond and height of the moment of impact against the batter's leg pads. Finally, it applies complex physics algorithms to calculate the ball's probable path moving forward. It is mathematically mapping the exact route the sphere would have taken if the batter's body hadn't physically stopped it. By doing this, the software eliminates the umpire's blind spot, allowing us to accurately observe a physical event that never actually finished happening. All of this complex, multivariable math is then instantly distilled down into a highly simplified binary graphic for the officials and the fans at home. The final output demonstrates whether that projected path would have harmlessly missed or ended up crashing directly into these 3 wooden stumps. That conclusive data is immediately relayed back to the field, unfreezing time. This collaboration allows the on-field umpire to confidently raise his finger, signaling an out based on the system's verified logic. This technology was never designed to completely replace the human official. Instead, it exists to provide objective spatial data that empowers their authority. Hawkeye shows exactly how predictive modeling and synchronized camera arrays can augment human perception, ensuring fairness in the most high-stakes moments of the game.